This is the CVT of this B209. It's a Killing-mawngap to 20 kV line. Alright, now let us go to our Y phase. Okay, we'll go to Y phase. This 209 CVT in junction box. We'll go to the junction box, a little bit detail about this, so that if in case we have to do any maintenance work or to check whether the fuse up there, which is inside that box, they are okay or not, we'll have to first measure the voltage from this junction box. See, this is the PLCC. Also the PLC carrier is tapped from the Y phase. The high frequency carrier is tapped from here. That's why we have to trap the high frequency carrier. That means there should be a low pass filter, that is our wave trap, is connected so that it doesn't allow the high frequency wave to enter our substation. It will only enter in this high frequency wave will be diverted to this Y phase. This is the cable that you see here, an extra cable is there in Y phase. This is just it is just a secondary carrier only. It carries the high frequency, and it will be unless we divert it to the ground, it is going to go to our PLCC panel inside. Now let us just go inside this CVT junction box, or we call it potential transformers in case of our 33 kV substations. So inside this it will be like this. All right, now the very first one, as you see there, these are power circuit which are not required for us to understand. We'll just understand that there are three sets of terminal box here. The first one is terminal box number 1, number 2, and number 3. Right, the first one is, see, our CVT is actually a 3-core CVT. So the first one, terminal box number 1, represent core number 1. Core number 1, then the phases will be in the sequence R, Y, B, like this. Okay, as you see from the nameplate. Okay, you see from the nameplate, it will be R, Y, B, and the sequence of connection, it will be, the connection will be, you see from the nameplate, the terminal connection will be, this is 1A and this is 1A, and this is 1N. Okay, it come from there, it come from the CVT from above. And then this is also 1A, 1N, 1A, 1N, but the only difference is that it is for R phase, Y phase, and B phase. And same for this core 2 also, it will be 2A to N of R phase, 2A to N of Y phase, 2A to N of B phase. Same way for this also, this is core 3, so it will be 3A, 3N of R phase, 3A, 3N of Y phase, 3A, 3N of B phase. And the connection have also been done in the same way like this. For example, R1A is connected to terminal B1 number 1, and then 1N is connected to terminal number 5, and then 1A of Y phase is to terminal number 8, and then 12 is 1N of Y phase, and then 1A of B phase is connected to 13, it's 14, and then 1 end of B phase is connected to terminal number TB1 of 19. Okay, that is the connection done. It is done for all actually. And just to remind you also that this is incoming, I mean it come from the CVT to this, and then from here we tap to our relay. Okay, to our REL or REC 670 or REL 670 from here only. And also this is core 1, which is used for protection, core 2 also protection with a 3P accuracy class, and this is core 3 is used for measurement with an accuracy of 0.2. okay, 0.2 accuracy class. So this is a little bit, so like when you have to see whether our CVT is correct or not, what we actually do, we just measure with the help of a multimeter. We just measure the voltage of this 1A with respect to earth. Also you can do or with respect to 1N. If you measure these two, it will be the secondary 110 by root 3, it will be around 65. okay, it will be around 64, 65. And same way, if you measure the voltage between these two terminals, it will be 64, 65, like that. Same way for this B phase also, it will be 62, 65. And same can be done for other cores also, core 2 and core 3. This is R phase, core 2, it will be 64, 65, like that. R Y phase, core 2, 64, 65. And in the same way you can do for all. And if you want to measure, for example, RB phase, you should get around 110, and you take this is 1N and 1N of R, and this is R Y phase, okay, or this with this, or this with this will be a YB like that, or RB like that. Okay, so this is how you measure the voltage, and I'll be just showing you also how you measure, and I'll be proving also that you are getting the correct value or not, because this is just a new line. So I think you will be getting the desired voltage of desired secondary voltage of 65 64 65 like that, because this is our newly commissioned 220 kV lines that goes up to Mawngap. Okay, so everything from Killing we have already seen from RBCU relay, it's reading the correct value. So you should be getting the correct value here also while doing with a multimeter. So we'll just see how it is done. So let me just measure the value, and you can say, at the same time also read the multimeter readings, and then let us measure 1A. You should get around 65. Okay, 1A and 1N of R phase. So how much you are getting? It is 60, around 64. All right, around 64. All right, I should be getting around 64. Okay, 65. And then if I take it this also will be around 64 65. Okay, fine. And then 1A 1N of B phase will also be 65. But if I have to take like line to line, let me take R and Y. How much you're getting? It should be 110, roughly 110, 111, which is fine. And then Y and B phase, YB, VYB voltage VYB will be no, take with line to line 114, which is fine. And then I take RB, also will be 111, something like this. Okay, and same thing can be done for other cores also. For example, if I do this and this, we are getting 134. And mostly we actually measure this with respect to Earth. For example, if I have to measure this, the very first one with respect to Earth, how much am I getting? I should be getting around 65, with respect to Earth. And with this one end with respect to Earth, because it's zero voltage, you should not get any voltage. And this is 2A of Y phase with respect to Earth, you are getting 65, which is fine, because of phase voltage. And then if you measure it with 2N, you should get 0. All right, which in fact you're getting. And then this B phase, 2A of B phase, you are getting 65. This is the Earth. And then with this you should get 0. And this can be done with for core 3 also, which is the measuring core. All right, so this is all about this how we measure the voltage using a multimeter from the CVT junction box. And this is also one way of actually somehow detecting or finding whether the fuse up there are okay or not, because unless you measure the voltage, you wouldn't be knowing, right? If you're getting the voltage, okay, fine. But if you're not getting, that means you have to open the CV junction box and open like I did. Then only you will be somehow get an idea what is happening up there. And then once you're not getting the voltage like I did, then you can directly with the nameplate that is there in front of you, and also the connection light you see on the screen, you will be able to tell exactly like what is the the problem. And mostly problem with CVT light in 90% of the cases, or you can say more than 90% of the cases, is only related with our fuse, because every CVT is provided with a fuses, right, for better protection of our CVT also. Or your marshalling box or your junction box look like this inside. The very first one, as I already mentioned, core 1, core 2, core 3 like this. And then let us for study purpose, we'll look at the core number 1, and see the numbering has been given like this: 1A 1N R phase, 1A 1N Y phase, 1A 1N B phase like this. Okay, when we take the measurement also, I will just give you the measurement. When you have to measure, like you have to measure 1N with respect to 1A with respect to 1N, then you will be getting around 63.5 like that, right? And then when you take 1A with respect to Earth also, you just do it with multimeter, you should get roughly 63.5 volt, as per the measurable voltage, secondary voltage of 110 volt. Because every time whatever is the primary voltage, whether it's 132 kV, 220 kV, or your 400 kV also, all will be stepped down to our measurable
line voltage of 110. And if you want to take it single phase, because in this case I want to measure this particular phase, for example 1A with respect to earth, then I just multiply this 110 by a factor of root 3, then I'm getting 63.5 volt, right? What does it mean? It means that when we look up about core 1 also, if you take a multimeter and measure 1A with respect to 1N for core 1 for all the phases RYB, and same for core 2 to A with respect to 2N for all the phases RYB, and core 3 also for all the phases RYB 3A with respect to 3N, you should be having value of roughly 36 to 3.5. okay, and it may go up or down depending on your primary voltage. If your primary voltage is a little bit higher, then this will also go up by the same proportion. All right, so one thing is also to be noted that your this 1A 1N of the core 1, they are all connected to 1 point. Okay, so that's why when we tap also, we just tap it from this one end of R phase is looped with one end of Y phase, is looped with one end of B phase, and then from here we take it to the relay, okay, of core 1. And same thing it's done for other cores also. And one thing, it's just that we all know that our potential, this 1N 2N 3N, they should be all at the same potential as earth potential. That is, ideally should be 0 volt, but we may get some voltage also, it's fine. And that's why when you take 1A with respect to earth, 2A with respect to earth, 3A with respect to earth, is same as measuring 1A with respect to 1N, right? That all will be reading value of approximately 63.5. And you can take a face-to-face voltage also by for example, we take a core 3, the measuring phase. Okay, this phase in 3A with respect to 3A, that is 3A of R phase with respect to 3A of Y phase. That means you are measuring the voltage VRY. In that case, your multimeter should read 110. As I said, it may go up or down depending on the primary voltage. And same thing, if you want to know the value of your line voltage VYB, that is VYB, like that. Okay, you have to put your multimeter in 3A of Y phase, and the other should be in 3A of B phase, and then your multimeter in the same way it will read 110, and that is your line voltage. So I think this is understood, and for other queries you can ask in the description box, not in the comment box. All right, so this much only for today.